Good. Hi, everyone. Welcome to a new session of live streaming with OpsMill. So today I'm with Alex Gittings, and we're touching on a topic I think that's really dear to our hearts at OpsMill. It's about branching, and so we're gonna try to cover in an hour without slide. That was the rule I told Alex, like no slide. That would have been shooting. So no slide, live demo as much as possible. What is branching? How does that work? I think the goal is we're actually, for the first time, gonna show you inside the database how it works. We feel like it's visual enough that even though you really don't have to worry about it and care about it, I feel like for the most advanced of you out there, that can be very interesting and to look on how it actually works internally and so very excited. If you're watching, of course you're watching live. Please feel free to ask questions anytime on LinkedIn, on YouTube. We're actually monitoring that. There's a little bit of delay, but we'll definitely see your questions and get to that. Are you excited, Alex? Are you ready to talk about branching?
Yeah, of course. Yeah, definitely.
Awesome. Do you want to? I know you had the agenda. Maybe that so you
Yeah, I
can
can
get
show
a
that.
bit of an overview of. Go for it. I'll let you.
So we're going to cover. Damien's going to cover why graph database, kind of under the hood of what we are using the graph database for, and some of the specifics in there, because we're using a graph database, but there's many techniques applied to the graph data to allow for the immutability and the branching concepts that we have. Once Damien's spoken around that, again, he might show the under the hood of how that fits together, and then we'll look at the different branching types. In Infrahub, we are not specifically related to Git in terms of branching. Is not it, for example, in Git, branching is very compartmentalized. Changes are in a specific branch, whereas in Infrahub it's been designed so there's multiple different branching types, and we'll go through those: the aware, the agnostic, the local, and we'll show you how branching works from schema data, how we can apply that with adding services, the output of what you might get in Infrahub, like artifacts, and how we can use these all together using some of the features of Infrahub, like resource managers, to apply data across branches, and so it's all aware of one another.
So that's a lot to cover. So how much time do I have to talk about why graph database? Because I thought that was like 50 minutes. It looks like you also plan for 45-50 minutes.
Yeah, well, go ahead and we'll see where we get.
No, I'm kidding. So first, let's pull an instance of Infrahub. I'm going to share my screen. And maybe I do feel like it's not in your agenda, but maybe even before talking about why graph, we should very, very briefly re-explain the concept of like, hey, why don't we put version control in a database? Because some people watching might not be familiar. So here I have an instance of Infrahub that on which I loaded the schema. The schema actually is something we use with some of our customers to build like very large data centers. So this one, for example, we represented the concept of a pod. A pod is a spine leaf fabric, and then you can connect pods with per spine. They're organized in fabric themselves. So we created this schema and already loaded some data just because I thought it was being more interesting. So just to be very brief, like this idea of Infrahub is that we can create branches, and Alex will talk about all the flavors of branches and all the things that we have in there. But just to be clear, and sometimes it's really there's misunderstanding every time we talk about we support version control. People are like, we expect that inside it works with Git. Where here that's not the case. Everything data is actually stored in the graph database that we're going to talk about. And from a user standpoint, this idea is that we can, go here, create a branch, and then we'll be able to, for example, make a change to this object. So if I edit this object, let's say I want to change the number of spine from 6 to 4, then now I have 4 in branch 2, and if I can switch back to the first one, I have 6. So it's really, if you're familiar with Git, we try to re-implement exactly the same concept inside the database. So that was maybe the simplest intro. And so what we want to talk about is how it works internally and all of that. So let's go back, maybe to step back a little. I'll take another object just because it's easier. So let's take a rack. I think I was looking at rack earlier. So rack is another object that we have in the database. And here, so first let's look at what is a graph database and how it works internally. And so one of the specificity why we picked a graph database is because when it comes to everything in our domain, it's all about trade-off. And usually a database, they're defined by how powerful is the schema, and then there's how powerful is the query engine. It's a bit simplified, but I think it's 2 aspects. And what we're saying is all the NoSQL database, for example, they have very, very loose schema. They make it very easy to store anything, but usually they have a less powerful query engine, where graph database, they're kind of in the middle. And I think this is super interesting because there's this super powerful query engine, and at the same time, they're very, very flexible on what we can store because of this notion of graph. So let's look at it. So the one we use internally, it's called Neo4j. It's the leading graph database. There's different technology. So if you want to try, all you have to do is expose the port 7474. If you use Docker Compose, not necessarily exposed by default, but if you expose that, you should be able to log in. I'm sure you can find the login and password. It's so the way it works is like it comes with this very powerful query engine. I did wrote some query so that I would not have to type everything. So this is a Cypher query, for example. And here I'm defining that. We'll see what it looks like first. Because I don't want to get the entire database. We're just going to filter on this specific object. So I'm inside the database, and I'm going to look at what this database inside looks like for this specific object.
Return.
And just to be clear, it's not something you have to.
I think you just need to return the path rather than match the path on the bottom line.
Thank you. So no one really has to learn all of that. It's like all that we're exploring right now, it is not required to work with Infrahub. You don't have to learn this query language. It's more like because we want to show how it works internally for more advanced users, for people who are curious to understand how the graph database works. Like technically, the main interface to access this data is GraphQL or the UI or the SDK. Like it is absolutely not mandatory to learn that. But yeah, just to show you, like the way it works internally is actually every object that we have in Infrahub is modeled as a mini graph itself. And so what we see here, for example, is we have one object that is where we find, for example, there's information that are defined in the schema. Like the kind of this object here is called location rack. That's what Infrahub see. So that's what we find here. And then we have individual nodes for each of the attributes. And then we have individual nodes for the value of those attributes. And why we're using graph is because graph, so first, super flexible. Like if I wanted to create a new relationship between, in the graph terminology, what's wrong, we call that a node, and the arrow in between, we call that the edges. That's the terminology. And in a graph, like you can add any type of edges between any two type of node, and there's no hard requirement, there's no limitation. And adding a new type of edges is not going to change the query that already exists or the structure of the graph. So that's one of the big benefit of that is it's very flexible from a schema point of view. Now, what's also super interesting is if you use graph in a specific way, the way we use here, there's this concept of a temporal graph, meaning every time we make a change, like a traditional database, when we make a change, we override the value that is currently in the database, and then we kind of lose the previous value. There are databases nowadays that are able to work like that, but there's always some limitation, and it makes the construction of that much more complicated. In a graph, there's this concept of a temporal graph. So for example, if I come here and if I make a change to this rack, let's say that now I want to change the index and say, let me change the number of leaves, probably going to be easier, and I'm going to change the checksum, for example, to something like that. So if I make those changes, now if we go back to the graph, what's interesting is we see that the graph is slightly different. And we see, for example, here that now for checksum, there's two values that are automatically attached to the node. It means that we haven't overwritten the initial value that we had for this node. We just expanded the graph and we started storing the new value, which now is here. It's like that's the new value of my object. And we store that. And what we define in this edge, we just define when that change happened. And we see that we also updated the previous one to say now that the value that is on the other side of this edge is only valid from this timestamp to this timestamp. So it's decided that that's why we call that a temporal graph, because everything that is captured internally is always defined by a timestamp. And every time, so here I'm making a query that's a query everything, but I could also make a query and say, I only want to see, for example, where, let me think of this one for a second. So if I look at where all the relationship in the path, rel dot, I haven't prepared this one. So if I probably should have prepared this one. The point is, I could also have filters in this query that would actually automatically select what are the paths that are active based on the timestamp. And that's what Infrahub does. Is like we do create those query on the fly, but if we query issues like right now, then we make sure that all the edges that have a time that limit their validity in the past then will not be returned, and then automatically we only return the value that is correct. That's why when we make a query in Infrahub, we can always go back in time. And here, for example, I can go back to a few minutes ago, and a few minutes ago, so it was still, but if I go back at 5 minutes ago, we see that I'm still in main, but I'm able to see the value that is actually active at this specific time. And we can do that because inside the graph, we haven't deleted that value. We just have defined that it's not the one that is active at this specific time. So that's the first concept of this temporal graph. It's super powerful. It means that, and the belief is that it really works really well with infrastructure management, because you always, from a traceability standpoint, you want to understand everything that has changed. You want to make sure everything is tracked, and we have full visibility into that. So that's what we do internally. Now, what we did with Infrahub is we added the concept. We added the concept of a new temporal aspect. Instead of having a single time, we added the concept of branch, so that if I create a new branch and I say, okay, now I want a branch 4, for example, in this node, then I will be able to change the value, for example, in this one. And we see that if I go back to main, oh, actually, it's interesting. So we're actually going to touch on that later. Like, there's some attributes that are what we call branch aware, branch agnostic, and it looks like I picked the wrong one here. So that was a bad example.
Easier mistake to make.
Yes, interesting. So let me pick an attribute that is actually not branch agnostic. I guess the name will not be right. So here I did the in branch 4. If I go in main, it is a branch agnostic. Actually, I need to check the schema to see which one is. So if we see the attributes here, for example, I see that the name, that's actually what Alex is going to talk about. It's called branch agnostic, and it's also one of the benefit of not using Git is we actually have a lot of flexibility into deciding what is going to be what we call branch aware and have version control enabled, and what we want to not have it. And I swear I did not prepare this one. Actually, it's a genuine mistake.
And just to highlight on
that is branch agnostic. So I guess this one, just to validate, is also branch agnostic. So is this one? This one is branch aware. So I guess I can change this one.
So for everyone kind of watching, you can define your attributes, relationships, and also the kind of object as those different levels. So your schema can be your node can be branch aware, and then your attribute can be branch agnostic. So you can have different levels.
Okay, so now it works. In main, I have a value, and then in branch 4, I have a different. Sorry about that. That was very much not planned. And so here, if we pull the graph again, what we see is first, since I made some mistakes, now we have more value for the checksum. It just happened that those, we'll talk about it, but since we're looking at it, like, because it's agnostic of the branch, it's actually labeled with a specific branch, but that was not the point I was trying to make. And now if I go to the amount of switches, we see that the value 1 now has multiple value and different validity. Like in main, it was active from in the past, and now it is the new value as well in branch 4 at a specific time. And so basically much by adding this notion of branch in this temporal graph, now we're able to support the branch. And then what we do in Infrahub is we dynamically generate the right queries to return the right value based on the branch. We do the diff. We are able to calculate, like, because we have exactly all of those information, and we're able to calculate all of that quickly. And you can see here, like, what's obvious when you see it this way, and that's also why we wanted to show the inside, is like creating a branch is actually a very, very light operation. Like if I create a new branch, I don't duplicate the data. I don't duplicate anything. You know, in many ways, like the time it takes to create a branch, it doesn't depend on the size of the database. The only things we do today when we create a branch is we duplicate the schema internally, and there's some of it that is loaded in memory, but it's there's no changes on the data itself. And I think that's the most important one, because as we see everyone trying to add version control, some solution out there, I'll keep name for myself, but they are like looking at actually completely duplicating the data. And I think the challenge when you do that is if you duplicate the data, it's easy to do. It's easy to do the diff, but then bringing back the data together and actually understanding what has changed is something that can be very, very complicated. And the copying everything sometimes, become a challenge as well. Where
Could also be quite storage intensive if you've got a large database. If it's being copied, whereas if you look at the whereas if you
so
look
here really having this multi-temporal graph, that was really a way for us to, if we summarize maybe before moving to the next sections, like leveraging the power of the graph database to so that we can have a super extensible schema. We have this ability to create, go back in time and we don't lose anything, and then we can capture also different branches without duplicating any data, without putting a big load on the database. So for all these reasons, that's why we picked the graph database. And the last reason is actually what Alex was talking is, I think Git was designed initially for software developers writing code. And in the concept in Git is that the branches are very isolated from each other. And we'll see actually there is a need in infrastructure to sometime we don't want everything to be isolated. Like resource allocation is one of those topics we talk about. But for us, we actually have this ability to, when we want, at some very specific points, make requests that are across all branches and that provide a global visibility, which can be very challenging sometimes when you just use Git and they are actually completely isolated and you don't have this global view. So we're really trying to navigate at the best of both solutions here.
So got a question from the community. How does garbage collection work here? Do you delete the nodes after some time passes?
So today we do not, but that's been definitely something at some point we're gonna propose or add. Like that would be pretty easy to say, hey, I don't want a history after a month, for example, and we can just erase everything after a month. But for now, we haven't done it. It's not. But if someone feel very strongly about it, please reach out. In Discord. It's not a big feature for us to implement. It's actually pretty easy because everything is already in the database.
Perfect.
Cool. I'll hand it over to you, Alex.
Yeah.
20 minutes.
Oh, you did well. You did well.
What if some attributes flaps between two values? Do you get stored as two nodes? So today for the value, there's a question. So what if some attributes flaps between two values? Do they get stored as two nodes, or does a new one gets created with the new timestamp? So today we're actually trying to optimize the storage by reusing the node that stored the value. And that was actually used in my example. I don't know if you saw that, like, where's the value 2 was we reuse that to avoid duplicating it. But we are duplicating the edges. Like we will have one edge for each change on each branch. That's the solutions we have right now. We're always exploring. It's always a matter of trade-off because sometimes when there's too many edges pointing at single nodes, like depending on how the query is written, it could work, behave differently. But we have a lot of tests for that, and we're actually making a lot of efforts to make sure we're tracking the performance and looking at way we can optimize the underlying way we're storing everything in the graph and how we write the query. So something we're tracking very carefully. Thank you for the question.
Good. Right, so going forward, everything that I will be showing will be using the Infrahub demo service catalog, so publicly accessible schemas and examples so that anyone can have a look. So we'll be looking at the different branching types. We kind of touched on a few there with Damien's example with branch aware and branch agnostic. So what does that mean? Sometimes you want the ability to have information shared across branches. A key a key reason we see this is you want the ability to have a service reserved across all branches so that people can't reserve the same service, and doesn't matter when the branch was created. If it was created yesterday and you create the service today, that branch that was created yesterday will be updated with that service that got created. So that's kind of the example we'll be showing on a service level in this. So the different branching types, we have three. We have agnostic. So what agnostic means is that it's not aware of the branch. It is across all branches, and that can be at the object level. So for example, if you say your devices are agnostic, when you create a device, for example, it'll be shared across all branches. We have some core schemas that use this. An example of that would be branches. When you create a branch in Infrahub, it is an agnostic object, and you see it across all branches. We have aware. Aware is the ability to have different data in different branches, so that isolation. They're aware that they are localized. And then we have local, the branch type of local, and that is any data that is created within a branch. When that branch is merged, that data is not merged back into main. I've personally not needed that for anything so far. So maybe Damien can highlight what local was used for. That might be a good one.
Primary use case when we created it was actually the way we track the commits in the Git.
Yeah.
Because every time there's a merge, there's actually the commit changes and everything. We didn't want to carry over the commit necessarily from one branch to the other, because we would always resync with Git. So that was the reason. Like we wanted to prevent. And in other places, like if there's a value that always gets recomputed anyway, then we would treat them as branch local, and to make sure that we're not creating unnecessary conflict. Like the attributes that are being modified by everybody all the time, then they will otherwise create conflict if you want to try to merge them.
Yeah,
that would be one way to avoid that.
I can see another purpose. It's like let's say you had a large generator that generated a lot of data, and you maybe wanted to keep some of that data within an object for a short amount of time for maybe reviewing purposes or temporary storage of that data rather than in memory, for example. You could then access the database, and then when it's merged and the branch is deleted, it's just gotten rid of. That's another use case I thought of it earlier as like a temporary storage within your branch.
That's a really good one.
You could do things like store JSON in a JSON field temporarily, or whatever you need, and then after a branch is merged, it's just discarded. Awesome. So they're the three types: agnostic, aware, and local. So I'll look at what that looks like in a schema. So we have a service schema here as part of that demo. We have a generic that creates some attributes, and that is it's a normal generic, so there's no branch information on here, so it is aware. And then in the attributes, we have the service identifier and the account reference. So these are agnostic. They're shared across branches. And we'll see that come to life. So we can see here the two attributes we are defining as agnostic. When this generic is inherited by our service, in this instance it's a dedicated internet service, we do pull over those attributes into the node. And we have status, which is branch aware. So this could mean that when I create a service, the service is reserved. It might be in a certain status for that branch, but as maybe things kick in like generators and they update the service to go from draft to provisioned or in staging or whatever the status may be, in that branch you'll see the specific status of that service. So it is aware. In main branch this might say draft, but if you go into the branch you'll see a different value for that. So draft, in delivery, active, you can see those statuses there. Bandwidth, also aware, because you might be wanting to change the bandwidth of a customer's service. You might want to create a branch for that. You don't want it to be shared across all branches. IP package, again, aware. And then we have some other ones as well. Relationships, branch agnostic. So adding the service to a location, for example. So that's at the attribute and relationship level. But what's important is that we can also specify the entire node as branch agnostic. So when you do create this, it's shared across all branches, as well as the attributes having their own certain rules as well. So you could be very flexible on what you share across branches and what you don't. So that's how you define it, specify the branch and type. We've got extensive documentation on those. So I'll show you this in practice and then see how we go.
Don't worry about it. I already did that.
Yeah. Another side of branches that Damien alluded to is that we use the branching system for schema changes. So anything you want to add or remove from your schema, you can do in a branch. So it's another level. It's not just data that can be that is branch aware and agnostic. It's also the schema. So I can go and add a new attribute in here.
And the way we do that is because the schema is actually stored as almost any other node. I mean, it has a different reserved namespace and all of that internally, but actually we're storing the schema inside the database itself, and so we benefit from all the temporal and version control aspects that we have in how we store data.
So if I just create a branch here and then load this schema into the branch, so it would be poetry run schema load and then schemas, and I'll just specify the service. Oh, I almost forgot my branch. So I'll just load this schema into that branch. We should get a thumbs up that it gets loaded. You can do a check command to verify that it would be okay. So if I go back to my Infrahub now, I'll be able to see that there's 2 branches. If I go to my service and dedicated internet, in the main branch, we have no services at the moment. The name attribute is not present. But if I go to my my schema, I see the new field added, the test attribute that I added, and in main it's not. And the standard merge process will, if you were to go through a proposed change or just merge the branch directly, will merge the schema into the main schema as well. Perfect. I'll clear off this branch. Let us know if any questions arise during this. So I'm going to highlight the different branch agnostic, branch aware types now with adding a service. I'm just going to use a dummy service portal to do that, that we created using Streamlit. And what this will do is take in a service identifier and count reference. So I'm just going to say customer X, can specify a location, specify a bandwidth and the IP package. And this will go through a bunch of stuff, but what it's doing is creating a branch, it'll add the service and open a proposed change in the background. I'm just doing this for simplicity to demonstrate the more fundamentals. So if we go back to our service now, we can see that that service portal has added the service to Infrahub. We can see the service identifier, the customer, the status. Now, some of these attributes we discussed earlier were branch agnostic, like the service identifier, the account reference. So if we go to the branch that was created, we can see that the same data is there. However, the branch aware objects, which were status, bandwidth, IP package, are branch aware. So if I flip between the different branches, we can see those branch aware fields being populated because they're specific to that branch. They are aware of their location in the graph, which is good.
To bring that to real concrete example, I think it's like we have one customer, for example, looking at creating a branch for each new service that is being deployed. I imagine probably takes a few days or a few weeks for each of them to be completely deployed and before gaining production. And so in this way, you still have the visibility, full visibility into what are different service actually and what are the stage, and whether if we had a branch that was staying open for a few weeks, and then you would miss that visibility. So it's from the API standpoint, you can still see all the internet service object.
Yeah, definitely. So we can see in the background a generator has been triggered to generate a lot of data for this service and apply some things. Damien, do you reckon there's anything to add about the vendor agnostic and the branch agnostic and branch aware attributes at this point before I move on to
I think we covered a good part of it. Again, most of the time you don't have to worry about all of that, and it's just branch aware, and I think that's the way people like it. It's, again, this session we're trying to go deeper and show the capabilities and talk about them. So, but yeah, most of the time it's just branch aware. That's the way things are. So
yeah, definitely. Okay, so as part of, I'm going to move artifacts towards the bottom. So we've added our service, we've got data in our branch and shared across branches. In this instance, the service is shared across the branch and some data is shared only in the instance in the branch. So I'm going to look at resource managers. Now, resource managers are quite important. When I deployed this service, we said we wanted an IP scope of a certain point, a certain amount. We have these items called resource managers, and there's 3 different types: prefix pools, IP address pools, and number pools. These are branch agnostic pools, so they're shared across branches. So for example, to highlight this, if I want to deploy a customer service like we had just done, we want to allocate an IP address or a prefix from a pool. But if someone else creates another service in another branch, we don't want to allocate the same prefix that's already been allocated. So I can demonstrate this. So we've got the customer prefixes. I can see in there it's got one resource. The utilization is at 3%. I can go and view the resources that were divvied out by this resource manager, and we see it's 0/29. If I go and create another service, let's say SI 1001, and submit another request, although the branch has not been merged, it's that both are in kind of draft status. If I go back to my service, we can see both services are in draft. We'll be able to go back to the resource manager and see for this prefix pool.
It's worth mentioning. Sorry, Cody, finish what you were saying, and then
we can go back to the resource manager and see that the same IP address wasn't given out. So this the resource manager was able to allocate even though the services are in different branches.
Yes, and I realize, talking about branch agnostic and branch aware and jumping to that, it may feels like we're actually or that it will require, for example, the nodes or the attributes to be branch agnostic itself. And in this case, that's not the case.
No.
Like actually the object, if we go to the object, maybe like the object are branch aware, and so they only exist in the branch, but it's just that the resource manager in this case has the visibility into all the branches, and it's kind of another a special way of exploring that. So yeah, we just to be clear,
It's a good point to highlight.
Is completely branch aware here, and we're not using the previous features that we talked about.
Yeah. /29, and if I go to that other service, we can see it 8/29, and we can't see the other IP address that was allocated. It's a very good point that I almost missed. Okay. So that's shown the prefix, but it's also, again, for numbers, we can do the same. For example, when we created the service, we allocated some VLANs for this service. And again, you can specify the pool, the range that you want to allocate from. And again, it will assign an IP address. And if you decide you don't want this service anymore and you delete the branch, for example, this number will be put back into the pool to be reused, and when you allocate a new service. So instead of starting at 1002, it will go back to 1000, for example, and reuse what was there. Perfect. So what I wanted to highlight with the output of a service like this is Infrahub has the ability to generate artifacts. They're kind of the output of the data that you might want to render a configuration, a security policy, a Terraform vars file. We are able to see these artifacts in Infrahub. So I'm on the main branch now, and I can load up, for example, Brussels. I can see the data that's here, and we can see that it is a pseudo config. It's not a real config, but it's got enough data to make this viewable. In the main branch, we have data here for the interfaces. And if we go to the specific branch here that has that service, we can see, for example, in this branch, we're adding VLAN 1000 in that example. And if we go to the other branch, we're adding 1001. This is kind of blending both the branch capability with actual object files under the hood to see that we're not only doing data branching, but we can see the branching on the object files as well. We can see this change more prevalent in a proposed change. For example, if I go to the artifacts in a proposed change, I'll be able to see the difference between the main and the branch I'm making a change on, and what the impact of the changes within the database have made to the output of the configuration or any artifact that you're generating with Infrahub. Any additional information you thought I missed, Damien?
No, I think you covered the main point.
Yeah. Under the hood, Damien, when we store the object files, are we storing a file per branch, for example?
We're actually storing the object files based on their checksum. So if the file hasn't changed, or if the checksum is the same, it's going to be the same.
The same. Yeah.
The same object. Yes. Yes. I realized that I forgot. I don't know how many more topics you had to cover, Alex, but it looks like since there hasn't been too many questions, I realized there's actually some additional things I wanted to show on the graph database part that I forgot. So
Of course, yeah.
we
They're the
could get
base
back to
main.
that.
Yeah.
But if you're done, or was there more you wanted to cover?
No, they're the key concepts I think we use branching for. The schema, data, and really the service was like a good use case of those branch types. Resource manager, which is using branching as well, and artifacts. Yeah. So that's all I had.
Maybe one point then I don't think we covered here is how we are, and Infrahub is also able to synchronize, make sure like you have the branch in the database,
Mhm.
but you can also have the same branch in Git in some situation,
Yes.
which gives you the ability to make a change, for example, to your Jinja template, to some Python code, and having a branch pretty much that's spread across the database and the Git, which in some cases is very important. We're not creating all the branches in Git by default because sometimes you don't need to make a change in what's in Git, but it's also I think something that's very powerful. Like sometimes when there's I think tools that are integrating with the external Git repository that don't support branches, they technically only sync with one branch. Where for us, we can actually sync with an entire Git repository, and you could have like multiple branches in Git syncing to different branches in Infrahub. And anything we actually, that would be maybe another topic another time, is like how we do that. Like internally, we're actually, I think, using an interesting system on how we're storing the Git repository so that all the files remain available in all the branches at all time. Which makes it possible to run Jinja template within each branch individually, and same to execute Python code and all of that. So I think it's one of our specificity as well. Probably could have prepared for that. I forgot now.
Yeah, I'm using a read-only repository as well on this example.
Yeah, so that won't work. But
Yeah.
internally, we're actually constructing. Anyway, that's another topic for another day.
It is.
But yeah, maybe if you want, I can go back to actually the graph
yeah.
database, because I forgot. I wanted to show, I think, something that is very powerful with the graph database. Oh, sorry. Do you mind if I take over the screen?
Yeah, Jennifer will be able to move it over.
Awesome.
There we go.
So back to the examples we had earlier. And if we go back to so here we have this graph. Now, what is very powerful as well is I mentioned like the graph database is the query engine, and we picked Neo4j because it's a very powerful query engine. So if we look, for example, at this object, this object is connected. That was the rack we had earlier. It's connected to a pod, and the pod is connected itself to an object of type fabric. It's actually part of a hierarchy. So here it's a fairly small hierarchies, but it's a hierarchy. And what's important is sometimes one of the power of the graph database is sometimes you do not know where is what you're actually looking for. Like you have this concept of what we call a traversal query. And it's especially like when you have a hierarchy, it's super, super powerful. Because here, for example, I say, okay, I didn't explain properly those query earlier, but like I'm starting from a node that has a label of type location rack, which is this one. That's the label that we have here. We'll make it in yellow so that it's clear. So that's my location rack, and I'm gonna give it the label n. And so here I'm saying I want that the node n only match if I have specific UID, which in my case is the node I'm looking for. And now here we're actually making a query that say I want to navigate edges that have this is related attribute. So each edge have a specific name as well. So here is as attribute, but another one that's called is related. And we say that we don't know exactly how many of those edges we want to traverse. But in this case, I'm putting a limit. I say I want to go from anywhere between 1 to 5 in the graph. And I want to show me what is of type networking building block on the other side of that relationship. And so I don't really know what's the full structure of the graph, but I just want this query to return those kind of information. And so if I do that, you see that he actually returned and in that actually. So here we actually see the hierarchies that we have defined, meaning this is my pod object. So this is the pod. And here we have the fabric object. And so I was able to actually traverse the relationship and found that I'm connected to a pod, and this pod is itself connected to a fabric. And that's actually how we get those information. So that's, I think, is something super. And if the hierarchy was much bigger, then I could still get to it and get those kind of information. And so we're actually using that in a few places where it's something we actually need to start exposing more APIs, I think, internally, because this kind of query works really, really well with networking, where you could say, hey, show me all the paths between those two objects. And then the query will actually show you, for example, all the active cabling between two endpoints. And, that could be one, or that could be many if you have an ECMP or things like that. So we actually had multiple query for customers to expose these kind of capabilities. And, for us, it's a no-brainer. We definitely want to do that, because this kind of query is typically something that is really hard to do in a relational database. And in that, where graph databases are really, really good, like this traversal query. Yeah, I just wanted to show that. I thought that was pretty powerful. So if you want to play with the language, it's called Cypher. It's very well documented. Again, no one has to learn that. It's more for fun. I would not recommend to go and make any change to the database directly, because we have a certain expectation on how the graph is structured. Like, you should never make a change on your own. All the changes needs to go through GraphQL. But if you're interested, you can take a peek and be familiar with that. So yeah, that was I think the one we wanted to cover.
No, it's a very, very on topic one. We somewhat have discussions with the customer at the moment, which is very much tell me what is related with, the idea is like a virtual relationship and being able to link to objects, and this kind of touches on that of, I know what my destination node is, the kind of it, but I don't know how it got there, how many of them are there. This is a very good use case for that.
Yeah, that's definitely one way of covering. I'm curious, actually, Alex, do you know Cypher? Do you have some time to go and take a peek? Or
Yes. Yep. But it's one of those things, plenty of Googling and looking at the source code to navigate my way around.
Yeah, the query that we build can be a bit intimidating at times. But
yeah,
again,
for
that's
anyone watching, if you have any Cypher, you want to admire some nice Cypher, go and look at the core of the Infrahub repository.
Yeah, there's some, but that's where it's so powerful. It's like the database managed them very well, so it's pretty cool. Nice. I think we're pretty much at time. I think we covered everything I wanted to cover. There's been a few questions, but
yeah, not so many, but
not so many.
I think we've covered all of them so far.
And if anyone has any follow-up questions anyway, can join us on Discord or
Yep.
just on LinkedIn or YouTube, anywhere. We usually try to keep up and respond.
Yeah, and if you have any other ideas for other kind of deep dive sessions like this, please let us know. We're always after ideas. We have a list, but we'll get to the end of that list at some point.
Yes, absolutely.
So yeah, let us know.
Thank you. Thanks, Alex.
Thank you.
That was great.
No problem.